Welcome to my channel, The Proper Guidance. Here we are today to discuss about chapter number 8, database concept of class 12 computer science. So, here is the chapter where we learn file system, database management system, relational data model and keys in a relational database. First part, introductory part. After learning about importance of data in the previous chapter, we need to explore the methods to store and manage data electronically. Let us take an example of a school that maintains data about its students, along with their attendance record and guardian details. The class teacher marks daily attendance of the students in the attendance register. The teacher records P for present, A for absent against each student's roll number on each working day. If class strength is 50 and total working days in a month are 26, the teacher needs to record 50 into 26 records manually in the register every month, right? As the volume of data increases, manual data entry becomes tedious. Following are some of the limitations of manual record keeping system. So, entry of student details, roll number and name in the new attendance register when the student is promoted to the next class. Writing student details on each month's attendance page where inconsistency may happen due to incorrectly written names, skipped students' records, etc. Loss of data in case attendance register is lost or damaged. Erroneous calculation while consolidating attendance record manually. The office staff also manually maintains student details, which roll number, name and date of birth with respective guardian details. All these things are here. But finding information from a huge volume of papers or deleting or modifying an entry is a difficult task in pen and paper based approach. To overcome the hassles faced in manual record keeping, it is desirable to store attendance record and student details on separate data files on a computerized system so that office staff and teachers can simply copy the student details to the new attendance file from the old to new one, right? Find any data about any student or guardian, it will be easier. Add more details to existing data whenever a new student joins the school. Modify stored data like details of student or guardian whenever required. Remove or delete data whenever a student leaves the school. All these actions will be taken in a very simpler way when we use it is in a computerized system. So it will be easy to handle all these tasks, right? Now, here is the concept of file system. A file can be understood as a container to store data in a computer. We all are familiar with this term file. Each and every system we have to save some file with required extension, right? So, files can be stored on the storage device of a computer system. Contents of a file can be text, computer program code, comma separated values, etc. Likewise, pictures, audios, videos, web pages are also files. Files stored on a computer can be accessed directly and searched for desired data. But to access data of a file through software, for example, to display monthly attendance report on a school website, one has to write computer programs to access data from files. Continuing the example of attendance at the school, we need to store data about students and attendance in two separate files. Shows the content of student file, which is 6 columns. See here, this is a file named as student where all the required fields are here, which is maintained by the office staff. So here is roll number, student name, student date of birth, GNAME means guardian's name, guardian's phone number, guardian's address. All the details are here, and this is a table, and we give the name of this table student. Clear? So, table 8.2 shows another file called attendance. Here is another file which has 4 columns as detailed below, that is names as attendance. Attendance file maintained by class teacher only. So this is another file which is named as attendance file, which is maintained by class teacher. Now, limitations of a file system. Limitations of file systems. What are the limitations we have to face in a file system? File system becomes difficult to handle when number of file increases and volume of data also grows. Following are some of the limitations of file system. First point is difficulty in access. Files themselves do not provide any mechanism to retrieve data. This is the first point. Files themselves do not provide any mechanism to retrieve data. Data maintained in a file system are accessed through application programs. While writing such programs, the developer may not anticipate all the possible ways in which data may be accessed. So, sometimes it is difficult to access data in the required format and one has to write application program to access data. So, this is our very first point about limitations of a file system, that we have some difficulties in accessing the required data from a file. Okay. Next point, data redundancy. What the word redundancy means? It means repeating. Redundancy means same data are duplicated in different places in the file system. In our example, students' names are maintained in both the files. Besides, in table 8.1, students with roll numbers 3 and 5 have same guardian name, and therefore same guardian name is maintained twice. Both these are examples of redundancy which is difficult to avoid in a file system. Redundancy leads to excess storage use and may cause data inconsistency also. Clear? So, first point, difficulty in accessing data. Second one, data redundancy. Third, data inconsistency. Data inconsistency occurs when same data maintained in different places do not match. If a student wants to get changed the spelling of a name, it needs to be changed in SNAME column in both the files. Likewise, if a student leaves school, the details need to be deleted from both the files. As the files are being maintained by different people, the changes may not happen in one of the files. Okay. So, in that case, the student name will be different in both the files. So, this is a problem of data inconsistency. Next, data isolation. Both the files presented at table 8.1 and table 8.2 are related to students. Okay, but there is no link or mapping between them. Both the tables are different. Okay, the school will have to write separate programs to access these two different files. This is because data mapping is not supported in file system. In a more complex system where data files are generated by different person at different times, files being created in isolation may be of different formats. In such case, it is difficult to write new application programs to retrieve data from different files maintained at multiple places, as one has to understand the underlying structure of each file as well. Okay. Next point, data dependence. Data are stored in a specific format or structure in a file. If the structure or format itself is changed, all the existing application programs accessing that file also need to be changed, otherwise the programs may not work correctly. This is data dependency. Hence, updating the structure of a data file requires modification in all the application programs accessing that file. So, this is the concept of data dependence. Next and last one, controlled data sharing. There can be different category of users like teacher, office staff and parents. Ideally, not every user should be able to access all the data. As an example, guardians and office staff can only see the student attendance data but should not be able to modify or delete it. It means these users should be given limited access read only to the attendance file. Only the teacher should be able to update the attendance data. It is very difficult to enforce this kind of access control in a file system while accessing files through application programs. So, these are the limitations of a file system. So, when we face some limitations, we want to overcome this particular things from limitations. We want to overcome from these limitations, and this is overcome by the next concept, that is database management system. Limitations faced in file system can be overcome by storing the data in a database where data logically related. We can organize related data in a database so that it can be managed in an efficient and easier way. A database management system, or database system in short, is a software that can be used to create and manage databases. DBMS lets users to create a database, store, manage, update or modify and retrieve data from that database by users or application programs. Some examples of open source and commercial DBMS include MySQL, Oracle, PostgreSQL, SQL Server, Microsoft Access, MongoDB, and all these things. A database system hides certain details about how data are actually stored and maintained. Thus, it provides users with an abstract view of the data. A database system has a set of programs through which users or other programs can access, modify, and retrieve the stored data. The DBMS serves as an interface between the database and end users or application programs. Retrieving data from a database through special type of commands is called querying the database. In addition, users can modify the structure of the database itself through a DBMS. Databases are widely used in various fields. Some applications are given in this. Banking, use of database in real life applications. Application banking, database to maintain data about customer information, account details, loan details, transaction details, etc. Crop loan means Kishan credit card data, farmers personal data, land area and cultivation data, loan history, repayment data, etc. Inventory management, product details, customer information, order details, delivery data, etc. Organization resource management, employee records, salary details, department information, branch location, etc. Online shopping, items description, user login details, user preferences, etc. Now, file system to DBMS. This is concept, file system to DBMS. Let us revisit our school example where two data files were maintained, table 8.1 and table 8.2. Let us now design a database to store data of those two files. We know that tables in a database are linked or related to one or more common columns or fields. In our example, the student file and attendance file have roll number and S number. S name means the student name as common field names. In order to convert these two files into a database, we need to incorporate the following changes. S name need not be maintained in attendance file as it is already there in student. Details for a student can be retrieved through the common field roll number in both the files. And next point, if two siblings are in the same class, then same guardian details are maintained for both the siblings. We know this is a redundancy, case of redundancy, and by using a database we can avoid this. So let us split the student file into two files, student file and guardian file, so that each guardian data are maintained only once. Okay. Next point, one and more guardians can have the same name. So, it will not be possible to identify which guardian is related to which student. In such case, we need to create an additional column, say GUID, means guardian ID, that will take unique value for each record in the guardian file. The column guardian ID will also be kept with student file for relating these two files. Okay. We could distinguish guardians by their phone numbers also, but phone number can change and therefore may not truly distinguish guardian. Okay. So now figure 8.1 shows the related data files for the student, guardian and attendance file details. Note that this is not the complete database schema since it does not show any relationship among tables, student, guardian and attendance. There are 4 fields for student, 4 fields for guardian and 3 fields for attendance table. Now the tables shown figure 8.1 are empty, which are to be populated with actual data shown in table 8.4. Snapshot of student table. See here, roll number 1, S name, author Ahuja, date of birth this one, GUID this one. So this is the student table. Now this is the guardian table and this is attendance table. Okay. So figure 8.2 shows a simplified database called student attendance, which is used to maintain data about the student, guardian and attendance. As shown here, the DBMS maintains a single repository of data at a centralized location and can be used by multiple users, office staff, teacher at the same time. Key concepts in database. Now we read about key concept in database. In order to efficiently manage data using a DBMS, let us understand certain key terms. First, database schema. Database schema is the design of a database. It is the skeleton of the database that represents the structure. The structure means the table names and the fields, columns, the type of data each column can hold, constraint on the data to be stored, if any, and the relationship among the tables. Database schema is also called the visual or logical architecture, as it tells us how the data are organized in a database. Clear? So, here is a diagrammatical representation of that particular theoretical portion. See here, there are the office staffs, here is teacher, query, DBMS software process query, DBMS software access database and its definition, database catalog, student, guardian and attendance. What is the query? About that query, it will find the appropriate result, and here is the answer. Query result is given to teacher, either to teacher or either to office staff. Clear? So this is a graphical diagrammatical representation of student attendance database environment. Next, data constraint. What is data constraint? Sometimes we put certain restrictions or limitations on the type of data that can be inserted in one or more columns of a table. This is done by specifying one or more constraints on that column while creating the tables. For example, one can define the constraint that the column mobile number can only have non-negative integer values of exactly 10 digits, right? Since a student shall have one unique roll number, we can put the not null and unique constraint on the roll number column. Constraints are used to ensure accuracy and readability of data in the database. This is very, very important. We will discuss it elaborately later in this chapter. Now, metadata or data dictionary. What is metadata or data dictionary? The database schema, along with various constraints on the data, is stored by DBMS in a database catalog or dictionary called metadata. A metadata is data about the data. And database instance, what do we mean by database instance? When we define database structure or schema, state of database is empty, that is, no data entry is there. After loading data, the state or snapshot of the database at any given time is the database instance. We may then retrieve data through queries or manipulate data through updation, modification or deletion. Thus, the state of database can change, and thus a database schema can have many instances at different times. Query. A query is a request to a database for obtaining information in a desired way. Query can be made to get data from one table or from a combination of tables. For example, find names of all the students present on attendance date. This is a query to the database. To retrieve or manipulate data, the user needs to write query using a query language called, which is discussed in chapter 8. Data manipulation. What is data manipulation? Modification of database consists of three operations: insertion, deletion or update. Suppose given joins as a new student in the class, then the student details need to be added in student as well as in guardian files of the student attendance database. This is called insertion operation of the database. This is called database. In case a student leaves the school, then his or her data as well as her guardian details need to be removed from student, guardian and attendance files respectively. This is called deletion operation of the database. Suppose author's guardian has changed his mobile number, his GPhone should be updated in guardian file. This is called update operation of the database. Next, database engine. Database engine is the underlying component or set of programs used by a database to create database and handle various queries for data retrieval and manipulation. Okay, so these are the very basic concept of, look here, key concept of DBMS, Database Management System. Now we will discuss about relational data model. Relational data model. Different types of DBMS are available and their classification is done based on the underlying data model. A data model describes the structure of the database, including how data defined and represented, relationship among data, and the constraints. The most commonly used data model is relational data model. Other types of data models include object-oriented data model, entity relationship data model, document model, and hierarchical data model. This book discusses the DBMS based on relational data model. In relational model, tables are called relations that store data for different columns. Each table can have multiple columns where each column name should be unique. For example, each row in the table presents a related set of values. Each row of table 8.5 represents a particular guardian and has related values with guardian's ID with guardian name, address, and phone number. Thus, a table consists of a collection of relationships. It is important to note here that relations in a database are not independent tables but are associated with each other. For example, relation attendance has attribute roll number which links it with the corresponding student record in relation student. Similarly, attribute GUID means guardian's user ID. GUID is placed with student table for extracting guardian details of a particular student. If linking attributes are not there in appropriate relations, it will not be possible to keep the database in correct state and retrieve valid information from the database. Now, look at this picture here. Here is guardian, student, and attendance. In guardian, there are 4 columns, right? GUID, GName, GPhone, and address. Now, in student table also, there are 4 columns: roll number, student name, student date of birth, and guardian user ID. Now see, guardian UID is the common column for guardian table as well as student table, and this student table is also related to attendance table, where we can see that there are 3 columns here: attendance date, roll number, and attendance status. So roll number and roll number. The column roll number in student table is same as the roll number column in attendance table. So this is the representation of student attendance database using relational data model. Clear? Now, relation schemas along with its description of student attendance database. See here, relation schema. Student, roll number, S name, S date of birth, and UID. Means, roll number means what? Roll number, unique ID of the student. S name means name of the student. S date of birth means date of birth of the student. GUID, unique ID of the guardian of the student. And for attendance table also we can see that attendance date means date on which attendance is taken. Roll number is roll number of the student here. Attendance status, whether present or absent. Okay, note that combination of attendance date and roll number will be unique in each record of the table. And next, guardian table. Here also GUID, unique ID of the guardian, name of the guardian, contact number of the guardian, and contact address of the guardian. Okay. So, each tuple means row, and for each tuple in a relation corresponds to data of a real world entity, for example, student, guardian, and attendance. In the guardian relation, each row represents the facts about the guardian and each column name in the guardian table is used to interpret the meaning of data stored under that column. A database that is modeled on relational data model concept is called relational database. Okay, so let us now understand the commonly used terminology in relational data model using figure 8.4. All these things are here, and now relation guardian with its attributes and tuples. These are the very important term you have to know, students, and you have to just very clearly understand this concept, that what is attribute, what is tuple, what do you mean by domain for a relational database model. This is a very basic concept of this chapter. So, attribute, characteristics or parameters for which data are to be stored in a relation. Simply stated, the columns of a relation are the attributes, which are also referred as fields. So, fields and attribute are of the same meaning. Okay, this is attribute. For example, GUID, GName, GPhone, GAddress are attributes of the relation Gaussian. Clear? So, what do you mean by attribute? This concept is clear to you, right? Next, tuple. Each row of data in a relation table is called a tuple. In a table with n columns, a tuple is a relationship between the n related values. Clear? We have already discussed tuple previously, right? Next, domain. What is domain? It is set of values from which an attribute can take a value in each row. Usually, a data type is used to specify domain for an attribute. For example, in student relation, the attribute roll number takes integer values and hence its domain is a set of integer values. Similarly, the set of character strings constitutes the domain of the attribute sname. Clear? Okay. Next, degree. What do you mean by degree? The number of attributes in a relation is called the degree of the relation. This is very, very important. What do you mean by degree in DBMS? In our DBMS, we understand degree means the number of attributes in a relation is called the degree of that relation. Clear? For example, relation Gaussian with 4 attributes is a relation of degree 4. See here the Gaussian table. Where is the Gaussian table? See here. GUID, GName, GPhone, GAddress. So 4 attributes are here. That's why 4 attribute. That's why this is known to be degree 4. Clear? And next, cardinality. What is cardinality? The number of tuples in relation is called cardinality of the relation. For example, the cardinality of relation Gaussian is 5, as there are 5 tuples in the table. 5 tuples in the table. See here, 1, 2, 3, 4 and 5. 5 tuples means 5 rows are here, and that's why number of rows means the cardinality, number of attributes mean the degree. This is degree and this is the cardinality. Okay, so this is the very basic concept. And now 3 important properties of a relation. 3 important properties of relation. In relational data model, following 3 properties are observed with respect to a relation which makes a relation different from a data file or a simple table. Property 1 imposes following rules on an attribute of the relation. Each attribute in a relation has a unique name. Sequence of attributes in a relation is immaterial. And property 2 governs following rules on a tuple of a relation. What is it? Each tuple in a relation is distinct. For example, data values in no 2 tuples relation attendance can be identical for all the attributes. Thus, each tuple of a relation must be uniquely identified by its contents. And sequence of tuples in a relation is immaterial. The tuples are not considered to be ordered, even though they appear to be in tabular form. Property number 3 imposes following rules on the state of a relation. That is, all data values in an attribute must be from the same domain, same data type. Each data value associated with an attribute must be atomic, cannot be further divisible into meaningful subparts. For example, GPhone of relation Gaussian has 10-digit numbers, which is indivisible. No attribute can have many data values in one tuple. For example, Gaussian cannot specify multiple contact numbers under GPhone attribute. A spatial value null is used to represent values that are unknown or non-applicable to certain attributes. For example, if a guardian does not share his or her contact number with the school authorities, then GPhone is set to null. Okay. So keys in a relational database. Keys in a relational database. The tuples within a relation must be distinct. It means no two tuples in a table should have same value for all attributes. That is, there should be at least one attribute in which data are distinct and not null. That way, we can uniquely distinguish each tuple of relation. So, relational data model imposes some restrictions or constraints on the values of the attributes and how the contents of one relation be referred through another relation. These restrictions are specified at the time of defining the database through different types of keys as given below. Okay. Number 1, candidate key. A relation can have one or more attributes that takes distinct values. This is known as any of these attributes can be used to uniquely identify the tuples in the relation. Such attributes are called candidate keys, as each of them are candidates for the primary key. Okay. As shown in figure 8.4, the relation guardian has 4 attributes, out of which GUID and GPhone always take unique values. No two guardians will have same phone number or same GUID, right? Hence, these 2 attributes are the candidate keys, as they both are candidates for primary keys. Okay. Next, primary key. Out of one or more candidate keys, the attribute chosen by the database designer to uniquely identify the tuples in a relation is called the primary key of that relation. The remaining attributes in the list of candidate keys are called the alternate keys. Okay. The remaining attributes in the list of candidate keys are known as alternate keys. In the relation guardian, suppose GUID is the chosen to primary key, then GPhone will be called the alternate key. Clear? And next one, composite primary key. If no single attribute in a relation is able to uniquely distinguish the tuples, then more than one attribute are taken together as primary key. Such primary key consisting of more than one attributes is called composite primary key. In relation attendance, roll number cannot be used as primary key, as roll number of same student will appear in another row for a different date. Similarly, in relation attendance, attendance date cannot be used as primary key because same data is repeated for each roll number. However, combination of these 2 attributes, roll number and attendance date, together would always have unique value in attendance table, as on any working day of a student would be marked attendance only once. Hence, roll number attendance date will make the attendance relation composite primary key. Next one, foreign key. Foreign key is used to represent the relationship between 2 relations. A foreign key is an attribute whose value is derived from the primary key of another relation. Foreign key concept is very important in relational database. If people please understand it properly. This means that any attribute of a relation which is used to refer contents from another relation becomes foreign key if it refers to the primary key of referenced relation. The referencing relation is called foreign relation. In some cases, foreign key can take null value if it is not the part of primary key of the foreign table. The relation in which the referenced primary key is defined is called primary relation or master relation. In figure 8.5, 2 foreign keys in student attendance database are shown using schema diagram, where the foreign key is displayed as a directed arc originating from it and ending at the corresponding attribute of the primary key of the reference table. The underlined attributes make the primary key of that table. Look here, for student table, here is roll number, S name, is date of birth and GUID. In guardian, GUID, G name, G phone and G address. Now, look here, GUID, from GUID, here is an arrow and it means that this is reference key. This is the primary key. GUID is a primary key of guardian table, where GUID is another key in student table also. So, this is a foreign key. GUID is a foreign key to the student table, as well as roll number is a foreign key for attendance table. Okay. So, this is all about key concept in database system. All the very basic database concept is cleared in this chapter. You people please go through. This is all about database and relational database. All the definitions are here. You people please go through all this chapter. This is very theoretical portion. Next day we will learn the next chapter. Till then, take care and thank you for watching.